show me your cup and the spoon, yeah. Okay. Sareza, you made your drink already?
What, sir?
You made your drink already, Sareza?
Yes, sir.
No. We have to wait, yeah. We have to wait. It's empty. So you have to make one again.
Okay, sir. Okay, sir.
Okay. Now what I'm going to do now is to do an experiment with you, yeah. I want you to make the drink now. I will give you 5 minutes. Yeah. When you make the drink, be aware of what you are doing. Okay. So please remember all of the steps you are doing, and then we will discuss it. Okay. But you make it as usual. You make it as usual. Don't think too many things. Yeah. Just make the drink as usual. Then we will discuss. Okay. 5 minutes, and then we'll go back here. Okay. Yeah, when you are doing when you are making your drink, you can turn off your camera, and then we'll turn on again. Yeah. See you in 5 minutes. Okay. Yeah. Some of you are done with the drink making already. So I'm also done with me. Yeah. Don't show your drink to the camera. Yeah. It will spill over. If like this, then it will spill over. Don't do that. So yeah, I made my drink also. I don't know if you can see it. Okay. Since this is the early class, yeah, I want to ask you to actively participate in this class. Yeah. In every class, I will discuss many things with you. Okay, so don't be afraid to answer my questions. Don't be afraid to ask questions also. Okay, that is how we will learn together. Okay, so I will ask you to tell me what exactly you are doing when you make your drink. Anyone who wants to share their experience? Okay, let me start first. Okay, and then after that we will go to the students. Yeah. So this is the drink that I have. Okay. The first thing I do is that I pour this into the glass, of course. Pour this into the cup. Yeah. And after that, I pour the hot water in here. Pour the hot water, and then I stir it. But how much hot water I put? Do you know how much hot water I put in there?
No, I don't know.
Yeah, only I know, right? I am the one who adjusts the amount of the hot water. So how much hot water I put? Well, for me, I don't want a hot drink. I don't want a very hot drink. I want a warm drink. So I just pour enough so that I can blend the mix perfectly, and then I add another cold water to adjust the temperature. Okay, when I feel comfortable holding it, and then I go here. Okay, and then I also see the color. Okay, if the color is too pale, then that means the water is too much. Okay, and then if the color is too dark, that means there isn't enough water. Okay, I'm adjusting the temperature as well as the taste when I'm mixing this. Okay, that's what I did. I am adjusting the temperature, and I'm also adjusting the taste. And how I adjust the taste? By looking at the color. Okay, this is a very simple thing that we do. Okay, now can anyone share their drink making? No right or wrong, yeah? No right or wrong. Who wants to share?
Me, sir.
Oh, Sinta, okay. Yeah. Go ahead.
Actually, the step is almost the same with you, sir. But the difference is only in the when you pour the hot water, I pour the hot water until almost full of a cup, sir.
Okay.
Because I like a hot drink.
You like hot drink? Yeah, okay.
Yes.
And how do you adjust the taste, Sinta? Is it a sweet or the sweetness? How do you adjust the sweetness?
Just I remember when I make in every day, so I adjust the water until almost full of a cup, sir. So I remember the taste. Yeah.
I see. Okay. Yeah. Okay. Anyone? No, no right or wrong. Okay. I mean, we don't have to play logic in here. Everyone have different taste. And the most important thing is that you do something so that the taste is adjusted to yours. Okay, that's one thing. That is called feedback control. Do you get what I mean? You know what is your desired taste, desired temperature, okay? And then you measure it for yourself. You measure with your arm, what is the temperature that I want? Like this, okay? And then what is the taste? And then Sinta said she adjusts the height because she remembers that at this height I like the taste. Okay, that means she have done calibration previously, that she knows that at this height the taste is like this. Okay, if this less, then the taste is not good. Okay, that is called calibration, and she does measurement. Okay, so you have your desired properties, and then you measured what happened in the actual system. Okay, and then you do corrective action so that the property of the system is the same with your desired one. Okay, that is basically control system. Okay, feedback control system. How does the feedback comes? Okay, it is from your sensory, from your eyes. Yeah, Sinta measure the height using eyes, right? Are you using ruler? Ruler, huh? No, you use eyes, right? But that is still measurement. Okay. And what about the temperature? She knows that if she she wants hot water, okay, and then the temperature is measured by the tongue, by the lips. Okay, that is measurement. I measure also by my hand. I hold the cup here. I feel the temperature is enough, and so I take it out. So that is you, yeah. You do things like that. And what if we want to draw something? Yeah, maybe you can see can you see the screen now? Yeah, I'm showing something here.
Yes, sir.
Okay.
Yes, sir.
Yeah, basically this is what you do. Yeah, when you are making your drink, you have your reference input. Yeah, reference input could be your temperature, the taste, yeah, the color, No, I mean the temperature, the taste lah. And this is the output. Yeah, the output is what really happened with your system. Okay, there is a feedback path here. Okay, because you need to measure what really happened with your system. Okay. Right. Any question from that? Whenever you have a feedback coming from the system by using measurement and then you do corrective action, that is called feedback control system. Feedback control system. Okay. Right. I will take something. Please wait. Yeah. I'll show you another thing. Yeah, I'm back. So do you know this? Yeah.
Indometer.
Yeah, how do I call this? This is Indomie, but we call this our best friend during our capstone. Okay, this will be your best friend during your capstone. Okay, you do night work at night. You feel hungry, you take one of these. Okay, to fill up your energy. And then if you read something on the back, yeah, there is a instruction on the back. It says here, rebus mie dalam 400 cc 2 gelas. Air mendidih dalam 3 menit sambil diaduk. Sebelum direbus, campurkan bumbu, minyak, bumbu, dan cabai bubuk ke dalam mangkok. Okay. So this one is telling you what to do. They even measure the amount of water, 400 cc. Okay. So if you follow this, this is called open loop control system. You do not adjust the taste, but you follow the instruction. This is called open loop control system. But if you adjust the amount of water on your own, then it becomes feedback control system or closed loop control system. Okay. Well, yeah, Indomie rendang tastes better. This is what I have in my kitchen right now. So this is the thing that I can show you. I also like to eat, the neoguri ramen better than the Indomie. The noodle tastes better also. Okay. Yeah, I want to draw something. Maybe it's better to draw, yeah. Let me draw something. Okay. Yeah, can you see the paint here? Yeah, what I'm going to draw is this is your desired properties. Okay, let's make a box here. This is your desired properties, and then this is the what? This is the output. Yeah, this is the output, and then because we are going to concentrate on the feedback control system, feedback that we call feedback or closed loop. Yeah, it is called closed loop because we are closing the loop. Now I'm going to put minus and plus. Okay, output, and then we measure. We measure here. Measurement. Then we go up there. Okay. So what does it mean? The desired properties when you make the drink is that the taste or the temperature, you compare them with the actual properties that happens. Yeah, you compare them. Are they the same or not? If they are different, yeah, it becomes the what? The error. Okay, and this error you process into the controller. Control, and then this is your plant. Go to the output. So we are going to concentrate on designing this. Yeah. Sorry. We are going to concentrate on designing this, the control. Let's say you found an error between your desired properties and your measured output. What are you going to do? Okay, that's the idea. Let's say you think that it is not hot enough. You need more temperature. Maybe you go into the kitchen and then warm it again. Okay, you take panci, then turn on the comport, right? To increase the temperature. Yeah, in any case, when you find an error, discrepancies between your desired properties and what you measure, you do something to your system. Okay, if you don't do something to your system, yeah, that means you don't care. You really don't care with your desired one and the output. Okay. And yeah, by the way, this is called block diagram. Yeah, this is called the block diagram. And if you want the process of making the tea or coffee, you can make something like this, and you can derive the mathematical expression if you want. Yeah, it can come up with the a differential equation out of the coffee making. But that's not what we are going to do in this class. Yeah. Modeling human activities is difficult. Okay. Right. Before I go into the other example, anyone have question about this? Any questions? Not yet. So now you try to think. You realize the activity that you do every day. Activity that you do every day. Yeah. Some of them it can be represented by this diagram. Okay. The one who wear you know headscarf, kerudung. You wear jilbab, kerudung, yeah. You look at the mirror, right? Is it properly worn or not? Huh? If it is not proper, you make correction, right? That is feedback control. You like it or not, that is feedback control. And then Wahyu, you hear me, Wahyu?
Yes, sir.
You use headphone, right?
Yeah.
Yeah. How do you place your headphone on your ear?
As comfortable as possible, sir.
That is feedback control. If you think that it is not comfortable, you correct it, right?
Yeah, I adjust the position.
That's right. So it is in your life. So if you got D in this class, I will not forgive you. Okay, because you do it every day. Yeah. Even when you sit down here, okay, roughly you sit on the chair, right? Do you sit anywhere on the chair or you sit until you feel comfortable?
Yes, sir.
Huh?
I'm sitting on the floor. It's just my
Background effects.
Ha.
Yeah.
Yeah, that is control system also.
Yeah.
Okay. Maybe anyone use, lipstick. Use lipstick. Yeah, you pay attention to where you put your lipstick, right? Don't do lipstick up here lah, right? Cannot do lipstick here. Okay. You put over here, right? There is a track, the track on your lips, right? You do tracking in here. That is tracking. You do better than the robot. Okay, robot is very stupid. Stupid means doesn't have intelligence. Okay. Yeah. We are intelligent, not stupid. Okay. Okay, what else? Zulkifli, I think you just have your haircut, yeah? Is that so? I don't know. Last semester I don't see your hair like this.
Yes, I guess.
Yeah. So what if your hair cutter is not looking at you when he cut your hair? He needs to look, right, when he cut. Yeah. That is feedback control. So your hair will not be as good as this if they don't do feedback control on your hair. Okay. Yeah. What else? Okay. Okay. Those are all the examples in life. Yeah. Feedback control is being used. Now let me take you into an example where it is being used in the industry. Okay. So this is where we are going to use our knowledge. Yeah, we go to the industry, we play with mechanical system, electrical system, we have the model, design the controller, and solve people's problem. Okay. Sorry, when I share the screen, I haven't shared the audio, so let me do it again. Hard include computer sound. Okay.
Consequence of an overhead crane caused by the load's inertia. The load will continue to swing back and forth, which, of course, is unsafe due to risk of a collision. Now, if a collision doesn't lead to harm or damage, impatience might. If the operator gets impatient, they may put their body on the line to stop the load. Never do that, and an operator shouldn't even be put in that position. Luckily, these can all be solved with sway control technology. In this demo, the bridge is running at full speed and the operator lets off the run command at the green stripe. Notice the considerable difference in swing during a simple deceleration. Here's the same run with sway control.
Okay, so you know the difference, yeah? If you apply control, feedback control to that system, you can make the swing to be very close to zero. That is solving people's problem in the industry. Okay. And then this is
without vehicle stability control, when the front wheels slip, the vehicle will not turn into the curve even when the driver continues to turn the steering wheel. With rear wheel slip, the vehicle's rear will slide, and the vehicle may spin out, even if the driver steers into the skid. Vehicle stability control can help keep the vehicle on the intended course by making sure the direction of the vehicle and the direction of the steering wheel agree. If the vehicle experiences wheel slip, VSC can reduce engine power and slow down individual wheels with the brakes to help keep the vehicle on the intended path.
okay. On the example of vehicle stability control, you see this.
With rear wheel agree.
Sorry, where is it?
If the vehicle and the direction.
You see what are the color? Red color means when the vehicle sense that there is a understeer happen at the car, it it plays a control action to each of the independent wheels. Okay, applies the brake or applies more torque to it so that the position of the vehicle is adjusted. That is called the control action. Okay. Yeah, this is still an example. And then if you want to try, for yourself again. Yeah, last semester I did this to the students. Okay, you try to write on your paper, write anything. Yeah, and you compare when you close your eyes and then when you open your eyes, what is the difference? Of course, it will be better when you open your eye. Yeah. Okay. So that means for any kind of systems, you can always draw this block diagram for any kind of systems, right? So for example, in here, I can make this block diagram for writing, desired writing, actual writing, and then these are the plant, human body, pen, paper, table. All this is the plant, and this is the measurement system, human eyes. Okay, and then the human brain acts as the controller here. Controller. Okay. So what is a controller? Controller is the one who decides the control action. That just as the word says, controller. Painter, the one who paint, right? Writer, the one who write. Controller is the one who decides control action. Okay, now as a practice exercise, you can do exercise on this. Okay, 1.3. Okay, let us discuss this. You have people in here, and then there is a conveyor belt, and the conveyor belt is driven by a motor. Okay, and the speed of the conveyor belt is defined in here, right? Let's say you want a desired velocity on the conveyor belt, and then this switch over here, it can adjust the speed of the conveyor belt. Okay, so this is just like when you are applying a lipstick on your lips, right? Or I don't know, maybe combing your hair, something like that. Yeah, you see what's the actual output, and then you know what the desired one. Okay, and then you identify all of the system. Okay, so we can say this is the desired speed. Yeah, desired speed as the desired properties of the system, and then the output is the actual speed. Okay, so if you want to create a block diagram, start with the desired output and then the actual output. What are those? And then after that, start with the measurement. How do you measure the output? Okay, you go with the feedback path first, and then after that you compare, and then you think what will be the controller over there. Okay, so it's very easy to derive it if it is like that. Yeah, you start with this one. So let me. Okay, this is number one. Number two, you go here. You determine what is the output, and then you define what is the feedback path. Number three is over here. Feedback path. What are those? Yeah, speed sensor, it detects the speed. Yeah, but because over here the controller is the operator. Yeah, they need to use the eyes. Yeah, if you want to use speed sensor and then your hand move automatically, then you need to connect the speed sensor to your brain directly. Can you do that? Huh? Have you ever tried to connect cables to your head like this? That happens in the movie, right? Sensors connect to here and then you can move things. That happens in Pacific Rim. Pacific Rim, you know? Yeah, the pilot got cables attached to the bodies so that he know what happened with the robot, right? That's called sensors attached to the body, and then he can control the things. But this is not Pacific Rim already, yeah? You use the eyes to see what happened. So you need operator's eyes in the feedback loop. Okay? Yeah, mathematically, the speed sensor operator's eyes, there are some, transformation variables happen in here mathematically, but we don't know what for sure. Okay, the thing that you see, oh, this is 100, I see 100. So how do I translate the 100 that I see here to anything in my brain? Okay, that is so complex. We don't have to think about that for this case, yeah. But for the thing like the car, crane, and all of the mechanical things, we can model all of them mathematically. Okay. Yeah, this is just an example, so we can create the free body. We can create the block diagram. Okay. Any question about this? So later on, in your free time, yeah, make some free time. You try to practice. Yeah. You can choose this system. You can choose this one, or you can pick any system in your house and make your own block diagram. Yeah, practice to make the block diagram. Okay. Yeah, I will upload this one later. And by the way, you can also find the modules in there. Yeah, if you go here, lecture 1. Okay, they also tell you how to create the block diagram for one kind of system. Okay, so you can read that. And what about this one? Okay, the modeling of physical systems. We really don't have much time to discuss about the modeling. Okay, modeling means you have a mechanical system and then you create your differential equation and then go to the transfer function. Yeah, it's going to be quite difficult for us. No, we don't have time for discussing the modeling. So we will only discuss a very simple system. Yeah, like if you go to the assignment, homework 2, for example. Yeah, so we'll just play with this a damper, mass, spring. This is the thing that you have seen already, right? Okay. All right. And to add to the to the motivation, okay. What we are discussing right now is the basic of feedback control system. And the control system theory is very advanced today. what we are discussing in this class is nothing. It's really nothing. Okay, if you go here to the you find papers in here, Automatica, our IEEE transaction automatic control. For example, in here, yeah, if I press this, I give an example of publication in Automatica. If you try to read this, you know, yeah, one of the author is this one. Who is this guy? Let's see. Oh, this is me. Okay. Yeah, let me show you what happened in that paper. Okay. If you read this and then you try to see what is the problem. Okay. It's got a lot of things we've never seen before. What is this XI? There is an omega here, and the Zn. What are these? I cannot understand this. I mean, yeah. So we are really at the bottom of the mountain. Okay, it's very high. The knowledge is very high. And for those who try to go into the mountain, go higher and higher, yeah, they see the mountain, it never ends. It never ends. Okay. The knowledge is very fast. Not fast F, yeah, V, fast. So that when you try to learn higher or deeper and deeper, you find that, you know, we really know nothing about this word. There's so much thing we don't know. Okay. So if you want to appreciate this word, learn. Okay. If you learn, you will know that you know nothing. So that you can appreciate Allah Subhanahu wa Ta'ala. You can appreciate your parents. You can appreciate your friends. You learn. Okay. Yeah, and formula are all over the place in something like this. Yeah, I mean, so if you interested to learn about control system, so later on what we should do, you graduate from Sampurna, yeah, okay, and then you either learn from the authors from this journal. You search who are the authors, you learn from them, okay, or better still, you check the editorial board in here, you pick one of them, learn from them. Okay, they are really at the peak of this control theory. Okay, so that's how you pick your, you know, master degree, PhD degree. You try to go from here. Okay, so this is, yeah, just to motivate you, not to make you small. Okay, because when you learn deeper, you feel even more smaller, you know. Now you get like a big head. My head is very big because you know nothing. Okay, once you know better, you feel that you are even smaller than that. So if any one of you feel that you knows everything, I will no. Yeah, I will ask you to learn. Okay. So yeah, we have to end this class because we need to join the, you know, Studium Generale. And what I wanted to do is practice your block diagram making. Yeah. For any kind of system that you want, pick one system at home, practice. Okay, and then the homework will be yeah, as I show you earlier on, this will be the homework. Okay, just two problems like this. and the answer is not unique. Okay, the answer is not unique. Okay, one system you can make more than one block diagram. Okay, you can discuss with your friends on this. It's free. Yeah, this is homework. You can discuss with whoever you want. Okay, and then you submit to the D2L, and then if you forget you submit here, that's also fine. But don't forget there is a quiz in here. Yeah, that is due on Wednesday. This is also still about the block diagram. Okay. So that is all from me today. Yeah, I hope you enjoy the first meeting and you don't get low spirited. This class is very difficult. No, you don't see the difficult part yet. Yeah, if you think sir, this class is so difficult, just see the journals lah. Those are more difficult. This class is nothing. You have to feel like that, okay? I mean, yeah, just to motivate you. Okay. There are two things that important. Yeah, like I said, this is ODE transfer function. We are going to review this. You learn this on the differential equation and engineering analysis. We are going to review this again later on Wednesday. Okay. So I'll see you again. Stay in good condition and stay in one piece until the end of the semester. Okay. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, Pak Jati.
Thank you, sir.